So what I have here are pictures of 8 very common functions. And what you'll learn later, you might learn later, is how you can manipulate these to get a whole bunch of other graphs. So these are called the parent functions. And we'll just kind of go through them here. So the first one is the constant function. So if your function f of x equals a number, a constant, so in this case it looks like it equals 4, the graph is a horizontal line. The domain is all real numbers, and the range is just that one particular number, in this case 4. The identity function is the diagonal line, y equals x, so f of x equals x. You can see it there. The domain, again, all real numbers, and you can see also the range, the set of y values, is also all real numbers. Okay, so if you can kind of recognize these. So if your function equals a constant, right, it doesn't matter what the input is, your output is a constant. The identity function, it's called that because whatever you put in is what you get out. If you give it 1, you get out 1. If you give it 3, you get out 3. Okay. The squaring function says whatever you give me, I'm going to square. And its graph looks like this. It's called a parabola. Also has a domain of all real numbers. The range, you can see it starts at 0 and goes to infinity. So it's only the non-negative ones. The cubing function, so whatever you give me, I'm going to cube it. And its graph, right, is this kind of a swoopy wave. It has a domain of all real numbers and a range of all real numbers. Okay. Oh, I should say up here, this linear function, this is, the identity function is also, could be called linear. Okay, so we have linear, squaring, cubing. We have the square root function. So if f of x equals the square root of x, remember we only take the square root of positive numbers. So that's why the graph only lives over here in quadrant 1. We can only have positive x values and we only get out positive y values. So the domain is just the positive ones. Oh, I'll get it right here. So a square bracket, because we can do 0 and we go to infinity. And the range also start at 0 and go to infinity. Absolute value function. So this is just a nice V. We start, right, go through the origin there. The left side has a slope of -1 and the right side has a slope of +1, in case you are wondering. The domain, again, we can take the absolute value of any number, but we only get out, right, 0 and higher. And then 2 that you might not have ever seen before, and that's the exponential function. F of x equals b to the x. B is called the base. And its graph, so it has this asymptote over here on the left, and then it gets crazy tall, crazy fast. So, right, if you've been watching any of the graphs on the internet about the COVID transmissions, you should have seen this graph a lot this year so far. So even though it looks like it's 0 over here, it's actually not. So the domain you can put anything. You can raise b to any number. So that's -infinity to +infinity. The range, however, it's 0, but not including 0, and then, right, goes on to infinity. There are some restrictions on the base, right, we'll talk about that later. It has to be greater than 0, and it can't be 1. So that's what lets us have our domain of all real numbers. And then the logarithmic function, so that is it's the inverse. It undoes the exponential function. And my graphing calculator, it looks like it stops here. It doesn't. We have that asymptote here as well. It's just my graph won't show it. So this time the domain, it matches to the range of the exponential function. So it's 0 to infinity, and the range is all real numbers. So notice so the way you say this is log base b of x. So that's base b. It's the same base that we had over there. So those are kind of the parent functions and what their graphs look like. Now let's take a look at 2 that we have gone ahead and done some transformations on. And let's just see what we get for those as far as domain and range. So the first one, f of x equals the square root of 3 minus x. So let's just we can look at the picture, we can look at the equation. what is the domain? What x values do we have a graph for? Okay, so, right, the x is where we have the graph, right, all along there. So, but if we do interval notation, we need to put the furthest left number first, which is negative infinity, because it goes forever to the left, and then the furthest right number, which is 3, and then we can include 3, so we'll write that. Now I'm going to show you the algebra way to get that same answer. So the radicand, that thing underneath, 3 minus x, has to be greater than or equal to 0. So you can move the 3 across. So negative x is greater than or equal to negative 3. And then you can multiply both sides by a negative 1. And remember, when you do that, you have to flip your inequality. So x is less than or equal to positive 3, which is exactly what we have here in our interval notation. Okay, what is the range? What y values do we have? So again, if we look at our picture, right, the y values only exist from the x-axis and on up. So from y equals 0 up to infinity. X-intercept, remember, that's where your graph crosses the x-axis. Where does it cross the x-axis? Well, it crosses that where y equals 0. And y equals 0, that's right there. Right, so we set y equal to 0, or we look on our graph. And an intercept is a point. So we'll go ahead and write that as a point, 3, 0. And then the y-intercept, so that happens when x equals 0. So we would just set x equal to 0. So we want to find, right, f of 0, practice evaluating your functions. So that says that is square root of 3 minus 0, which is just the square root of 3. Now, it's not a nice number, but it's a perfectly fine number. So the way we would write that as an ordered pair would be 0, comma, square root 3. So let's go up here on the graph and just make sure that makes sense. So y-intercept is right here, right? And so 0, no movement in the x direction, and then square root 3 is between 1 and 2, so that seems reasonable. You can use your calculator if you want to get an approximate value to make sure. Okay, now let's just do some calculations. Let's complete the table. So if x is negative 6, what is f of x? So, right, we have f of negative 6. And you can try to read them off on the graph, but I don't think most of these are nice numbers. Some of them will be, but not all. So f of negative 6, square root 3 minus negative 6, minus the negative is plus a positive. So we have square root of 9, that's 3. Oh, that was a nice number. So you can check and make sure that's on your graph up there. X is negative 6, y is 3. Do the next one. F of negative 2, what do we get for that? All right, square root 3 minus negative 2, minus a negative, plus a positive, square root 5. Okay, that's not a nice number, so I'm just going to leave that. And when I'm saying nice, I mean rational. It doesn't end. It doesn't make a nice little integer or nice fraction. It makes it repeating or a non-repeating decimal. Okay, next one. F of 1. What do we have? Square root 3 minus 1. Okay, square root 2. There's another irrational number, so we'll just leave that there. And lastly, so this last one, what I do is I give you the f of x value, and you have to come up with the x value. So we're going to solve that a little bit differently, right? We're going to put the 1 where the f of x is, and then set 1 equal to the square root of 3 minus x. Let's solve for x here. So square both sides. And then, let's see, let's subtract 3. So negative 2 equals negative x. Multiply both sides by negative 1. So x equals 2. Oh, that's a nice number. That should be on our graph. We should be able to find the point 2, 1 on the graph. Let's just make sure. X equals 2 and y equals 1. Yep, it is there indeed. Okay, so let's do the next one. So this g of x, so it's the absolute value. So we have the v, and we have the absolute value of x plus 2 and then plus 3. So what's the domain? Yep, all real numbers. What's the range? What y values do we get out? Yep, 3 is the smallest one, and then it goes on forever up. X-intercept. Where does our graph cross the x-axis? Right, it doesn't, so there's none. Right, no x-intercepts. And what about a y-intercept? Can we see that there? It looks like 0, 5. Remember again, intercepts are points. Okay, one more time, let's complete our table. And I might actually just use the graph this time. So if x is negative 4, so right, x is negative 4, what is the y value? So I go up on my graph, I find where x is negative 4, and I'm going to go up, and I'm going to read off that y value, 5. Okay, let's do the next one. So x is negative 2. So if x is negative 2, I go to where x is negative 2, go up, get on your graph, read off the y value. Y value is 3. And I know you can't see both things at the same time, so I'm just writing those numbers in the table down here. I'll scroll and show you here in just a second. So the next one, if x is 3, what is y? So we're going to go to where x is 3, so that's over here on the right side, and now I'm going to go up and get on the graph and look across and read off that y value. That looks like an 8. Okay, last one is I give you g of x this time, and g of x is 7. What are the x values that give us a y value of 7? So I'm going to go to where y is 7 and get on your graph. And this time I can get on 2 places. So go find both of them and read off both of those x values. So it looks like negative 6 is one of them and positive 2 is the other. Okay, so I told you I'd scroll and show you my table. So I was just filling in those numbers as we went.